So we want to determine if the sequence is increasing, decreasing, or not monotonic, and also if it's bounded. So first let's consider a function f of x that equals x e to the negative x, and we're going to consider that for x greater than or equal to 1. That way this function has the same integer values as this sequence. So if we put 1 in this function, we get the same thing as the first term of this sequence, and 2 in here the same thing, and so forth. And so whatever this function does when x is greater than or equal to 1 is what the sequence is going to do as we look at those integer values of the function. So let's go ahead and take a derivative and see what's going on here. So we have a product rule. First times the derivative of the second, the chain rule gives us a negative there, plus the second times the derivative of the first. Let's go ahead and factor out an e to the negative x, so that would be negative x plus 1. Now as we're looking at this, and we're interested in this for x greater than or equal to 1, we see at 1 this is 0, and if x is greater than 1, we can see that we are going to get a negative number out. So here at 1, this derivative is 0, and greater than 1 is going to be a negative. And so actually if we tried something over here to the left of 1, we would see that we would get a positive out of this. And so this 1 is where the function is at a maximum, and that's actually where our sequence starts. So it's going to be decreasing from there. So this is a decreasing function. Now if we wanted to determine a bound, since 1 is its maximum, we could figure out the first term and we would have an upper bound. So we could express that as e to the negative 1 or 1 over e. So as we're looking at a bound, the upper bound is 1 over e. Now let's look at what happens as n goes to infinity, and as we look at this, we see that we have the first factor, n, is going to go to infinity, and the second factor, e to the negative n, is going to go to 0. So we have an indeterminate form. So let's go ahead and express this as n over e to the n. Now we see that both numerator and denominator are going to go to infinity, so we can apply L'Hopital's rule. And we've got the limit as n goes to infinity. The derivative of the top is 1. The derivative of the bottom is e to the n. So we can see as we let n go to infinity, we got a fixed numerator, denominator becoming large, so this is going to go to 0. So we have a lower bound on our sequence of 0.